In this video, I'm going to show you some examples of the problems from section 11.3, and along the way I'll show you the way that I sort of remember the product rule and quotient rule for derivatives. The basic idea, of course, is that sometimes we want to find the derivative of a function that, even though we understand how to find the derivative of the individual pieces, the function itself is more complicated. It's combined in a way that we don't understand how to work with. For example, in a problem like this, if we had x to the 8th and e to the x that were added together, then we know that we can just take the derivative of each part added together, and that's the correct rule. But the same thing is not true for a product. For a product, we use the product rule, which I like to think of this way. If I have one thing times another, and I'll just use a circle and a square if I can draw them. If I want the derivative rule for that, well, it's actually fairly simple. It's just each of the two things multiplied by the derivative of the other plus the other way around. So the fact that I know the derivative rule for each individual piece will actually be enough to find the derivative rule for the whole thing, even though it's not just taking the derivative of each piece and multiplying them together. So in this problem, the x to the 8th is what I have my box around. The e to the x is what I have my circle around. And so according to this rule, the derivative should be the first thing, the thing that's in the box, times the derivative of the thing in the circle. Now you'll notice when I do these, I am always unsure if I'll know the rules or not. And so you'll see that I just write down what the product rule says in one line and then actually do the product rule in the next line. And I do recommend that. It does make you write down one more line for each problem, but it avoids the case that happens a lot where you end up trying to do a complicated problem in your head as you've written the parentheses down. This way, all you're doing is saying exactly what the product rule says, and then you have the opportunity to go back and just write down the pieces that don't have a derivative on them. And when you do see a derivative, e to the x prime, you can actually just follow the derivative rule. And in that case, if you needed to, you could come over here on the side and do some scratch work and figure it out if it was more complicated. And the derivative of x to the 8th, of course, is 8x to the 7th. So this is fine for an answer. This can be simplified a little bit. You certainly don't have to for my test, but sometimes the course compass system will fuss at you if your answer is not simplified. It doesn't hurt to just put it in this way and see whether it needs to be simplified or not, and then just try to remember for the quizzes which ones require simplification. In this case, you see that each term has an e to the x multiplied in it, and so there's an e to the x that can be factored out. And so this is not a crazy thing to do. So it's e to the x times x to the 8th plus, and e to the x was times 8x to the 7th. So that's about as much as you would ever want to do. But like I said, the thing I wrote here is good enough, and so you shouldn't try to algebraically simplify stuff if you don't have to. The quotient rule is similar. It's a little harder to remember because products have the advantage that it doesn't matter what order you multiply things in. So 2 times 4, 4 times 2 mean the same thing. But for division, that's not true. 2 divided by 4 and 4 divided by 2 are not the same thing. So the quotient rule is going to you have to remember which way around the rule works. So again, I'm going to put a box around the top of the numerator and a circle around the bottom, and then I'm going to try to remember what my derivative rule should be. And the rule is that it's each of these things times the derivative of the other, just like before. But this time they're subtracted, and the answer is a fraction that has the square of the old denominator. Since the order of a numerator and denominator matter in a fraction, it makes sense that the order of this thing matters, and so you do have to remember that this first term has the denominator times the derivative of the numerator, and then the second term is the other way around. Since they're subtracted, it does matter the order of those two things. So it takes a little bit of practice to get the hang of it, but it's just as easy to use because, again, if I can put a box around the top and a circle around the bottom, then I can just first write down what the rule says to do. The rule says to write the denominator, and notice I'm using parentheses here because my denominator's actually got several terms in it, and I want to make sure I've got the whole thing that's circled there, times the derivative of the numerator. And again, I'm not going to do it. I'm just going to write down literally the derivative of what's in the numerator, and then minus the numerator. Times the derivative of the denominator. So again, I'm not going to do it. I'm just going to write 7x minus 1 prime to tell myself that I need to do the derivative of the denominator there. And at the bottom, I'll have 7x minus 1 squared, the old denominator squared. Then all I have to do is just do the one step, which is to go back and find the derivatives that I've written down up there. 7x minus 1 was just itself. Then I want the derivative of x squared plus 3, which I know is 2x. And then I will copy down the x squared plus 3. That's not a derivative. And I want times the derivative of 7x minus 1. The derivative of that is 7. And again, my denominator is 7x minus 1 squared. So again, this is good enough if you're in a non-algebra simplifying situation. And so you certainly should try typing exactly that into Course Compass. It's not crazy to multiply this stuff out and this stuff and then do this subtraction. But do be careful when you're subtracting a whole expression. You've got to subtract each of the pieces in there. So you've got to move that minus sign through the parentheses. So there are some things you can mess up with the algebra. So it's always best to not do the algebra unless there's a reason to do it. And we'll talk about a reason to do it in a minute.